Welcome back to my channel. As I told you, um, my last class, will be moving on to this data visualization with Matplotlib. In the last class, we used Pandas, um, and I told you that there are other ways to create visualizations aside using Pandas. My microphone was having issues, so let's go through the ones you did not hear. Yeah, we'll be very fast. So here we use the plots kind histogram for histogram plot, and I told you that you need to state x and y axis um, clearly. And yeah, we use the we did the box plot. Yeah, the box plot is, since this particular image here, this particular box here states the numbers, and the numbers of times still was tested, so the serial numbers in them, and then it creates, this is the median and this is the lower time class interval higher than the 100 and 0. Same thing applies with each of them. So you need to state y label and x label. For the area plots, we did the same, stated the x and y parts, literally insane, and it was nice, did our legend and all of that. So for the pie chart, so we used the pie charts and stated only the y-axis, as I said. And then for the scatter plots, we did the scatter plots and we stated both the x and y-axis, which was mandatory, which I said we would take from in the column in your data frame. So now what we'll be doing here now, we'll be using our Matplotlib. So if you scroll up, as you can see, we presented matplotlib.pyplot as PLT. Can you see? So let's run all our codes. Boom. It's working. Let everything reload and continue. Boom, 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 boom. Waiting. Boom. So now let's hashtag this matplot library. Okay. Boom. So we have our stuff indexed, right? So our data frame, we have it indexed. This is the index, is the serial number. So first thing first, in Matplotlib, what do? We plot our data using PLT. And PLT, first, we'll state our figure size. Our figure size should be clearly stated before plotting. Why? Because if you plot before stating our figure size, you have two charts, an empty chart and a non-empty chart. The empty chart representing the figure size you stated, while the non-empty chart taking the default figure size of the code. Did you get? So now you have plt.figure. So we'll literally be doing copy and paste here in most of them. Okay, we have PLT. Then, as I told you in the last when we were treating pandas, was it pandas here? When we were treating pandas, I told you that stating only plots line chart. So by default, plot signifies only line chart. So then we list our data here, and then we say PLT dot x label. So our x label should be serial number, okay. Then our y label, should give us this. Let's state our y label as points like we did in the last class. Then plt.show. What I forgot to tell you is our title plt. Silly. I'm so silly. Title. So our title should be line charts. Boom. So after value, after this must be treated, not integers. What are you saying? Oh, I'm sorry. So this should be fixed size. Fixed size. Should work now. So what was never closed? It was. Oh, I'm sorry. So you see never closed. Should work now, yeah. I'm sorry about that. That was just glitch in my code. As you can see, this states the line charts of everything was being stated here. Boom, 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 boom. Nothing out of the ordinary. So as you can see in the previous, same thing, same blue, blah. So now, that's just how you try to do your what? Your line chart. Then yeah, we'll be taking it the way I want. So let's move on to pie chart. Why I'm taking it like this is because I indexed my data frame. So I'm drawing all the charts that require the data frame to be indexed. So we'll go from the line and pie charts, then we'll use our area plots. Yeah. And let's see. So same thing goes with our just as I told you in pie charts, we state our y-axis only. Our y-axis. And for this, our y-axis, what's our y-axis? Let's use still, and then for the labels should be our serial number, which boom, not there. So we have to remove the index one way or the other. I'm sorry, we have to just remove the index. So clearly df should be equal to df. Let's reset index. Wow, I think this is clear. And then call out df. Wow. So it should be a serial number. So our serial number should be used as labels. Work. Okay. As you can see, this is a line chart, a pie chart. Sorry for those you saw. So this is a pie chart of what you saw there. So what are we doing next? Let's go to the area plot. So this pie chart represents just I forgot to remove this pie. Okay, represent this, and then what do we have to do? So let's go with we have done line charts, we have done pie charts. Let's do the area. So area charts, area plots is literally different from the pandas, legit pandas. So yeah, we use the field between. Yeah, you clearly heard it. It's called the field between. So what do? We use the field between, and then we state the x-axis and the y-axis clearly. Nothing being removed. So just copy this. How am I putting x label? So for the pie chart, we need only the y label. We need only the y label. So removing this, just don't need this. So for now, let's go on. We're doing our area chart. Now, since we have an area chart, just like the bar charts, I'll show you the bar chart. The number of areas specifies the number of columns. Okay, so we have to literally plot the number of times we have, the same number of times we have. We have to plot and plot again. Do you get till we get to the exact number of times we have in the data frame? Okay, so we are plotting and plotting again, giving us 5 times. Since we have the same 5 times we have the same 5 columns aside the index column. Do you get what I'm saying? So we have 5 columns aside the index column. So clearly we are plotting 5 times in the area plot. So we are plotting the same number of times we have in the data frame. Do you get? So we have 6 columns, alright? We indexed. I don't know if you're understanding. We have 6 columns, alright? We indexed the serial number, so it's remaining 5 columns. So now we are plotting 5 times. Okay, so we are plotting the same number of times as we have in the data frame. Do you get the same number of times as we have in the data frame columns? Do you get? So our data frame columns should be equal to the same number of times we plot the data frame. So I don't know if my English is confusing, but let's just practice it. Here we have plots. So here is the field between. So this field between states the x and y axis. For the x axis we have sun, and y axis we have steel. We copy this so we can just be replacing. Okay, so let's just keep replacing. So for the next one we have the cast iron. Okay, cast iron. Next one we have the aluminium. Next one we have the brass, and for the next we have the copper. Charts. Okay, as you can see, this is it. So let's show our legend. No artist label found to put. No artists with label found to put in legend. No, the artist whose label. Okay, I think we have to state our label. Here for steel, yeah. This is cast iron. This is cast iron. And this is not clearly state this label. Okay, so label here. Label here should be aluminium. So label here. This is brass, alright. And this here should be copper. Okay, as you can see, legends are being shown here, and this tells us literally what we want to hear. So the purple for copper, this for brass, this for aluminium, and that. So we'll be moving next to bar charts. Bar charts signifies just the same thing. So as I said, we have to plot we have to plot equal number of times as we have in the columns. You get we have 5 number of columns, we plot 5 times. We have 10 number of columns, we have 10 times. So the same number of columns we have should give us the same number of times we plot in the data. So you get we plot equal number of times as we have in the column. So yeah, just shift here to bar. That's just literally what we're doing. Since it's the same, as you can see, coding is easy. You don't need to stress yourself. Bar. I'm teaching you lazy coding. Yes, people say that, but come here. Bar. And here we have the bar chart. Plot, yeah, that's nice. This shows beautiful. So let's remove this legend. Crazy. Okay, I remove the legend. As you can see, are we moving the labeling? No, we don't need this. You don't. Do you need to label? No, I don't think you need to label. But as you can see, clearly stating, can remove this. And let's just leave it. It's not really compulsory. And I'll teach you another way to plot bar charts. Another way to plot bar charts, as I told you, I don't know if you remember in the last slide, I told you that you can create visualizations from a mixture of using pandas, from a mixture of pandas usage and then the matplot lib. So that's another way of doing it. So you can just use the df.plot and then every other thing you have is matplotlib. So that's just literally it. So you come here, just like here, okay, post here, and then you write your df.plots like you have always done. Your kind should be bar and nothing else. It should be even better, kind bar. Okay, boom, nothing else, nothing, no big deal. So you can also plot bar charts like this, nothing, you are not doing anybody harm. As you can see, it will be clearly stated points and pt.x label. So for your x label, you write the x label should be the serial number. Okay, boom, you have the serial number here. So we'll be moving on. So as I said, we'll be very fast. We have done the area charts, we have done the pie charts, we have done the line charts. So next, we'll be doing the histogram. So we'll be coming here, copy this. So histogram is very easy. All you need to do is just to state the x and y axis clearly. That's all you need. The x and y axis clearly. So that's all you need for histogram. So nothing really added, no much addition, no much subtraction. You're just on your own. Do you even need to state the x's? Okay, we have to index. Let's index. Let's go and read our indexing. So by indexing, the x-axis will be stated already. Boom. So let's come here. We have set our index as the serial number. So just come here and plot our histogram. Sorry about that. Histogram. And I said something. Histogram. Since you are stating your data, you have to state the amount of bins you want to appear. You get the amount of bins. So our bins, I love 30. The number 30 is so nice, and boom, shown. So you have 30 beams, and this is the histogram. So you can choose to write 10, which is the default. Boom, shows. So as you can see, histogram is like a type of bar chart, but it's being conjoined. So moving very fast, we'll be looking at okay, we have looked at our Instagram and we have looked at the bar charts, pie charts. Okay, the scatter plot. So scatter plot, similar thing, just stating our x and y axis. We have to state our x and y axis. So I don't know, since it's, let's say scatter. So let's see for steel and cast iron. Boom, shown. So let's adjust our size and our color. So our color should be, let's say, gray, which we used in the last class, gray, and then our size 700, then boom. So this is it. This is the 700 pixels and all of that. So let's forget to change it to histogram. No, scatter plot, and change it to scatter histogram. Boom, histogram, and call this. Okay, I think this is better. So are we missing anything? Nah. No, this is showing the SN. No. All we have to do is just literally color our data. Sorry. I'm sorry. So we have to remove this index, reset our index as usual. come here, reset index, boom, and then we'll call it, since we said our index was our serial number, so I'm resetting it so that we can literally access this. So df dot serial number, okay, for our x-axis, and df then for steel, should we do steel, boom, this does it. So scatter plot steel, okay, this is nice, this is so nice, so this is so nice. And let's see if we can recall all these. I want to really scatter the scatter plot. Cast iron, cast iron should have blue. Oh yeah, blue. Okay, brown. Okay. Next one should be what was it? Was it aluminium? Yeah, aluminium. Let's see. Let's make it black. Okay, and we're making brass. Brass should be purple. Really, does brass sound purple? Let's say aluminium should be. Tell me another color. Brass. Brass is looking like green. I'm trying to match them. Okay, and then the last one, copper. Let's see if they have gold. If they don't have gold, we'll try yellow. Oh, boom, beautiful. So we have represented all our charts here. We have scattered the scatter plots. Let's state it like that. So we have scattered the scatter plot. This just shows how beautiful it is. What did we do here? Did I stay here point? How am I doing? This automatically did the data frame. Okay, one has been indexed. Okay, alright, not bad. As you can see, this is just the points we have. 40, 45. It's showing here. So we should have done the same thing here. We did, but this shows. This is okay. Well, I think it's indexed. It should have indexed it as the x-axis. Not bad, since it did it as the y-axis itself. So it's an automatic something default. So this is our scatter plot. So I'm just literally showing you how to plot charts. So I'm not really going deep into finding solutions to every problem. So the last but not the least, we call it the correlation relation. It's called correlation. Correlation relates an object with another. You get, in a data frame, relates a data with another, how close they are, how beautiful they are when they look close, shows it in a colorful way. Do you get me? So what we use correlation for is just, sorry about that, just go copy this, something like this. Let's see. So first and foremost, before we do it, we have to do our correlation table. We have to make sure our table is well correlated. So df correlation. So you say df dot cor. So that's just it. That's the syntax. Oh. Boom. As you can see, correlation is being represented with numbers, nothing else. So we have this serial number. So I do not want this to show. So let's go and reset index. Let's go and set our index to this serial number. So I don't want our serial numbers to show in the correlation. It should be outside. So when we're plotting graph, okay, see, this is in correlation. So when we're plotting the graph, it won't show because it's an index itself. It's the remaining columns that will show. So what we have to do now is, as usual, pt.2. So from here, we'll just remove this. Since it's Seaborn, SNS as you can see, when you go to the top, you have Seaborn as SNS. So you come down. Is there anything I'm missing? I feel like I'm missing something. Is there anything I'm missing? You try to tell me. Pie charts, bar charts, line charts, histogram, area plots. Pie charts, bar charts, histogram, area plots. Everything's settled. Alright, so that's the box plots, which I'll be teaching you after the correlations. Let's see if we can go about it. How we can go about it. So SNS dot. What do you do? So a heat map. So heat map is used to show correlation relation. So this is just what we are going to carry. This is our df dot correlation. So this is what we're going to carry. Right? Then our CMAP, that is the type of heat map we want. So our CMAP should be what? So our CMAP should be cool warm. Let's use the cool warm. Are not true. So this are not being true states that our annotations, that our labeling, everything should be present. Do you get? Everything should show. So we see correlation. Let's map correlation. Okay, now these are being correlated well. As you can see, still to still 1. Anyone that has high correlation will be represented with the red color, a deep red, showing that it's been highly correlated, and the rest, as you can see, low correlation is being represented by -6, which is a deep blue. As you can see, -6, -0.73. These are really low correlated, and then you have the colors that are close to red. They also have high correlation. As you can see here, we have 1, and here we have the least correlated numbers. Boom. That's just how it is. So I said we'll be creating our box plots too. So I'm just gonna create box plots. So this will be box plots. Is there anything I'm not doing? As you can see, a box plot, this is it. So we did box plot in our previous, when I was explaining pandas. So now I can tell you that you can also use Matplot or even SNS to create box plots. And this this is box plots using XNS. So this shows is literally colorful. As you can see in pandas, this is pandas. Yeah, this is pandas box plot. Has its own color for SNS, and you can also use PLT. So this one shows just the materials, automatically does its own. You get? So this is the serial number for each of them. There is the amount of time the materials are being tested. Same thing in your pandas. That's why I love box plots. So it automatically shows it. This is the same. This thing, just that you have different coloring and all of that. So let's use PLT. Also use PLT to plot box plots. Boom. This is another color entirely. As you can see, they are literally the same. Long wick, shorter wick at the bottom, at the base. As you can see, this is longer wick at the base. Third one, same thing. So various ways of plotting box plots. So now we have come to the end of the class. Thank you all for attention, time well spent on my channel. Remember to hit the subscribe button, also the notification button, so that you can receive updates from me. Always keep up with my teachings and all of that. So I'm really happy to have you guys on board. Thank you so much. So let's go rehearsal. Like I said in the beginning, we imported all our library. So in our next class, I'll be using more of this NumPy. Is a calculation library. So we use it. So I'll be in my next class, I'll be doing the data cleaning, and next after that we'll be doing the exploratory data analysis. So as you can see, going through this, I've really gone far. I've done a lot. So sorry about my microphone. I've thrown it as trash. So thank you so much. Bye.